Hello, good evening, and welcome back to the next video lecture of magnetron oscillator. So today I will explain the equation of electron motion in magnetron oscillator. Okay. So the motion, which all parameter is being affected for the movement of electron in a magnetron oscillator. Okay, let me see that one. So equation of electron motion. Okay, equation of electron motion. So I will write that one. I will derive the expression for that one. So first of all, I write the equation of motion of electron in a cylindrical magnetron can be written as d square r by dt square, okay, minus r into d phi by dt square should be equal to E by m er minus E by m r b set d phi by dt. So I call this as equation A. Okay. So this thing we are taken from the equation for cylinder from the electromagnetic theory. Okay. So another thing is one more two equation is that is 1 by r d by dt of r square d phi by dt will be equal to E by m b set dr by dt. Okay. So this I will call this equation P. Okay. So E by m is given by 1.759 into 10 raised to 11 charge per kilogram. Okay, is the charge to mass ratio. Charge to mass ratio of the electron. And B naught equal to B set is assumed in the positive Z direction. Okay. So I will rearrange equation B, rearranging equation B results what? D by dt of r square d phi by dt, r square d phi by dt equal to, how can I rearrange? E by m b set r dr by dt, because other term r I bring into the this term. Okay, so that I can write as 1 by 2 1 by 2 omega c d by dt of r square, d by dt of r square. Okay, d by dt of 1 minute, d by dt of r square, d by dt of d by dt of r square. Okay, so I call this equation C, where omega c is nothing but E by m beta z is the cyclotron angular frequency, cyclotron angular frequency. Okay, E by m 2 into 2r into d by dt of dr by dt. Okay, so what it becomes, r2 and 2 can cancel. Okay, right, correct only. Okay, so I will integrate the equation C integrated dr square by dt. I can write a 2r into dr by dt. Okay, so that if you want I can write this one, that is, which implies d by dt of r square is nothing but 2r into dr by dt. So this becomes the equation for 1 by 2 omega c is nothing but E by m beta z 2r dr by dt. 2 and 2 get cancelled, you will get the original one, that is E by m beta z r dr by dt. Okay, anyway, leave it that one. Integrating equation C, that will yields what? You just integrate the equation C, what you will get? You will get, that is r square d phi by dt is nothing but 1 by 2 omega c r square plus a constant term. I call this equation D. Just 1 minute, I will just verify that one. Okay, r square d phi by dt equal to 1 by 2 omega c r square plus constant. Okay, that's correct. So I will write at r equal to a, where I will take a is the radius of the cathode cylinder, and I will take d phi by dt equal to 0, comma constant I will take equal to constant what I will minus 1 by 2 omega c a square. Okay, omega c a square. Then the angular velocity is expressed by being expressed by r square d phi by dt is nothing but 1 by 2 omega c. I will put that r square minus 1 by 2 omega c a square, because that I will constant time I will put that value. Okay, I will put a d phi d at r equal to a, where a is the radius of the cathode cylinder and d phi d equal to 0, the constant becomes equal to minus 1 by 2 omega c the a square. Okay, so your constant term becomes, when r square becomes equal to a, and with the d phi by dt equal to 0, your constant will be equal to 1 minus 1 by 2 omega c. Then I write then constant equal to this one. So that now the new angular frequency is expressed. I will just substitute star in d, star in d. So you will have the angular velocity is expressed by r square d phi by dt is equal to 1 by 2 omega c r square minus 1 by 2 omega c a square. Okay, I think it's clear for you. Now r square d phi by dt is nothing but 1 by 2 omega c r square minus a square, which is nothing but 1 by 2 omega c 1 minus a square by r square, because r square minus a square by r square. So if I bring this one here, that is d phi by dt, I can write it in this form, that is 1 by 2 omega c to 1 minus a square by r square. I think it is clear for you people. 1 minute. Okay, I will put that equation as equation, what is the equation number now? TE. I will put as equation number E. Okay, since the magnetic field does no work on the electron, since the magnetic field does no work on the electron, the kinetic energy of the electron is given by the kinetic energy of the electron is given by half mv square, right, mv square is equal to E into capital V, EF, call it as equation F. Okay, so now the electron velocity has r and phi component, such as v square is nothing but 2 ev by m, which is nothing but what, vr square plus v phi square. Okay, which is nothing but dr by dt the whole square plus r into d phi by dt the whole square. So that I called as equal to EFG. Okay, so at r equal to b, that is b is nothing but radius from the center of the cathode center of the cathode to the edge of the anode, to the edge of the anode, and V equal to V naught and dr by dt equal to 0 when the electron just grazes the anode, grazes the anode equation E and G becomes what? d phi by dt equals 1 by 2 omega c 1 minus a square by b square. Call this equation E, F, G, H. Okay. So that changes to b square d phi by dt square is nothing but 2e v naught by m. Call it as equation I. Okay. To E v naught by m. So d phi by dt equal to 1 by 2 omega c 1 minus a square by b square, which implies b square into d phi by dt the whole square is equal to 2 e v naught by m. You just substitute equation H in I. What you will get? B square 1 by 2 omega c 1 minus a square by b square the whole square equal to 2 e v naught by m. Call it as equation J. Okay. So I will just give a conclusion here. The electron will acquire a tangential, that you know that I have explained in the figure, tangential as well as a radial velocity. Okay, radial velocity. Whether the electron will just grazes the anode and return towards the cathode, depends on relative magnitude of V naught and B naught, relative magnitude of V naught and B naught. Okay. So the Hull cutoff magnitude equation, Hull cutoff magnitude equation is obtained from equation J, that is V naught C is nothing but 8 V naught, just substitute it one, m by E raised to 1 by 2 bar divided by B into 1 minus a square by b square. Call this as JK, equation K. Okay. So this means that if B naught is greater than B naught C for a given V naught, if the electron will not reach the anode, will not reach the anode, okay, reach the anode. Conversely, what happens means one minute. If B naught is less than beta, and electron will not reach the anode, and conversely what happened, the cutoff voltage that is V naught C is nothing but E by 8m P naught square B square into 1 minus A square by B square. It is JK, called it as equation L. Okay. Thus, that it means that if V naught greater than V naught C for given V naught, the electron will not reach the anode. The electron will not reach the anode. And thus, equation L is called Hull cutoff voltage. Hull cutoff voltage. Okay, underline the roots. It's very important. Equation L. And this equation also. Okay. Equation K and L is very important. Keep in mind. So, okay. So, this is something regarding the electron motion, which all factor that is being affecting the electron to reach into the to reach from cathode cavity to the to reach from cathode to anode cavity. Okay. So, that has to cross the Hull cutoff. If B naught is greater than B naught C only, then for a given V naught the electron will not. If B naught is greater than B naught C, then for a given V naught the electron will not reach to the anode, and conversely the cutoff voltage is given by V naught C is nothing but something what I have written here. Okay. So, this is B naught. So, next we can see the next video lecture, we can come across with the cyclotron angular frequency. Okay, thanks for watching this video. Thank you.